get the recorder going here. There we go. Okay, let's take a look at graphs of the sine and cosine functions. And first, let's take a note some facts. We've already said sine and cosine are periodic, and we'll see what that means graph-wise here in a second. But for y is equal to sine x, and for y is equal to cosine x, the book has a lot of different facts, and very fascinating facts, but not that useful. First one we're going to notice is they're periodic. Specifically, the period is going to equal to 2 pi. Well, let's graph one of these. Now, this is going to seem a little bit weird, especially if you read the book on it. We're going to graph y is equal to sine x. But how we want to think of this is we want to think of it as y is equal to sine theta. And we're going to build a t-chart like this. And it's going to start at 0. And our period is 2 pi, so your period is going to be right here. So 2 pi. Why am I putting this so far out? Let's try it again. 0 and 2 pi. Now this is always your period. It goes here. And this one is always your 0. Exactly in the middle here is 1/2 of your period. Well, we take 1/2 times 2 pi, that would give us pi. This is always 1/4 times your period. I take 1/4 times 2 pi, I get 2 pi over 4 or pi over 2. And this is always 3/4 of your period. So 3/4 times your period. Well, 3/4 times 2 pi gives us 6 pi over 4 or 3 pi over 2. And let me get rid of that x. I don't want that there. What I'm really going to put there is theta. That's our angle. Now we're going to treat it as x on our graph, but it's not the same x that's on the unit circle. Well, let's go take a look at the unit circle. If I can find it. There it is. Okay. So what we're going to do is we got 0 here, and this is going to be sine, so we're going to go look up sine of our angle. Sine of 0. Well, if I come up to 0 degrees, 0's right here. Sine is our y part, which would be 0. Now in this one, actually, let me write out the steps there. Maybe that might help. So what I'm doing is I'm plugging in. So this would be sine of 0. We're looking at just this right here. Do not confuse the x's and y's up here with the unit circle. And then here we're going to plug pi over 2 into theta. So we got sine of pi over 2. Here we'll plug pi into theta, so we got sine of pi. And here we'll plug 3 pi over 2 into theta, and we got sine of 3 pi over 2. And then here we got sine of 2 pi. Sine of 0. We already said here's 0 degrees. Sine is our y part, which is 0. Sine of pi over 2. Well, here's pi over 2. Sine is our y part, which is 1. Sine of pi. Here's pi. Sine is our y part, which is 0. 3 pi over 2. Here's 3 pi over 2. Sine is our y part, which is negative 1. And sine of 2 pi, I'm back to the beginning, so it'd be back to 0. Let's graph this. Here's try it again. There we go. Here's 2 pi, and pi is like 3. So this is 2 times 3, which would be approximately 6. Now here's pi. Here's pi over 2. And here's 3 pi over 2. So I'm putting my theta, my angles, on the x-axis. Now up here is just going to be our y, the normal whatever this column gives us. So I got 0, 1, 0, negative 1, 0. So if this distance is 6, half of this is about 3, and 1 would maybe be about there. Kind of gives you an idea. So then we plot points. 0, 0, it'll be right there. Pi over 2 and 1 be right there. Pi and 0 would be right there. 3 pi over 2 and negative 1 would be right here. And 2 pi and 0 would be right here. Now these have a curve to them. Like that. Okay, period is 2 pi. See how my graph starts here, goes up like that, goes down, comes back, and then back to the starting point, the same place where I started. And actually, if you look at this, if you were to do a little bit of manipulating on this, doesn't that look like a circle? If I were to take this piece here and put it onto this piece. So that's why they tie hand in hand with the unicircle. Now to say that this has a period of 2 pi means it starts repeating. So it keeps on repeating. Over on this side, I'm going to freehand, or actually I won't do that, because I know what it should be. There's symmetry, so it comes down to here. Goes like that. Use your imagination. Like that. So that's the graph over 2 periods. And you can see it just keeps repeating over and over. And that's what sine and cosine do, is they just keep going back and forth like that. Well, let's take a look at cosine. And again, we're graphing y is equal to cosine x, but you can think of it as our angles. We're going to build a t-chart again. This is always a 0. This down here is always our period. I'll put P for period. This is always half our period, so 1/2 P. And this is always 1/4 of our period, which would be pi over 2. And this is always 3/4 of our period, which would be 3 pi over 2. Now here we're graphing y is equal to cosine theta. So we're going to, I did x again, didn't I? Trying to break myself of that. It's my first semester putting theta there. Usually I put x. So we said theta is equal to 0, so I'll put in cosine of 0. Here we said theta is pi over 2, so I got cosine pi over 2. Here's cosine pi, cosine 3 pi over 2, and cosine of 2 pi. Well, if I go look at my unicircle, here's 0. Cosine is our x part, which would be 1. Pi over 2. Here's pi over 2. Cosine is our x part, which is 0. Pi is over here. Cosine is our x part, which is negative 1. 3 pi over 2. Cosine is our x part, which is 0. And back to 2 pi, cosine is our x part, which is 1. Like that. Okay. So I'll put 2 pi over here. Again, pi is like 3, so that's 2 times 3, roughly 6. And this would be pi. Here's pi over 2, and here's 3 pi over 2. Now, if this distance is 6, half that is about 3. Then 1 would be about that distance. That's kind of, you want to draw these halfway correct. If you don't put them into scale, what you're going to find is that every one of the graphs looks exactly the same, and they shouldn't. Okay, so our first point is 0, 1. So 0, 1 would be right there. And then pi over 2, 0 would be right there. Pi negative 1 would be right there. 3 pi over 2 and 0 would be right there. And 2 pi and 1 would be right there. Now again, you still have the same curve that the other one does. It's as good as I can get freehand. And then they repeat. So this is going to go like this. Like that. Boy, that's not drawn very well, but without putting points on, that's probably as good as I'm a free-handed. So that's over 2 periods. Now, if you look at my graph, you see that there's a... They look almost the same, don't they? It's just shifted. There's actually a formula for this, that sine x is equal to cosine of x minus pi over 2. Now, if you remember from college algebra, if we got a number inside with the x, it shifts. And it shifts opposite what you think. The negative pi over 2 would make you think it shifts left pi over 2, but actually it's going right pi over 2. Well, if I come down here and took this graph, and I shifted the entire thing pi over 2, this distance right here is pi over 2, I would actually get this graph here. So that kind of gives you the relationship between them. Some other things to notice is here's my high point, 1, and here's my low point, negative 1. We're gonna use the amplitude to help us figure out how high it goes and how low it goes. It goes forever in both directions, so the domain is always all real numbers. Your range, though, will be between negative 1 and 1, including those values. Same here. 1's my high point, negative 1's my low point, and it goes forever in both directions. So domain is all real numbers, and range is negative 1 to positive 1. Now, it'd be boring if... Actually, let's look at those on the graphing calculator, then I'll talk about more complex problems. Have to be in radians. So I'm going to go to mode. I'll press mode, and I'm already in radians. If you're not, down arrow to that line and press enter on radians. I'll press y equals clear sine, and then I'll push the X key, and then closing parentheses. Now choose graph, and see the 7th one says Z trig. I want to choose Z trig. Now I can down arrow to it and press enter on it, or I can press the numbers in front of it. So I can press 7. And there's our graph of sine x. Well, let's take a look at cosine x. So press y equals, press clear, put in cosine, X key, closing parentheses if you want. And again, I'll do zoom, and I choose Z trig. Now what does the Z trig do? It goes from negative 2 pi to 2 pi by default, which in a lot of cases is what you want. But you see we more or less got what I kind of sketched, though theirs is more accurate. Now if you have the form y is equal to a cosine of bx, or y is equal to a sine of bx. Now a and b are numbers. Then your amplitude refers to how high and how low it goes. Not that I can spell it. Amplitude is going to equal to the absolute value of a. Your period is going to equal to 2 pi over b. Now, if I just had y is equal to cosine x, there's no number for the cosine, no number for the x, it's just 1 and 1. And that's why amplitude is absolute value of 1, which is 1. So that's why it goes between negative 1 and 1. And your period is 2 pi over 1, which is just 2 pi. Well, let's take a look at some problems where we have different values there. So, number 1, we got y is equal to 5 cosine x. And it says determine the amplitude and period of each function without graphing. Well, let's identify our a and b. Now, a is the number that's before cosine, so a is 5. And b is the number that's before your x. Well, there's no number here, so it's by default 1. So our amplitude, we take the absolute value of a. So the absolute value of 5 gives us 5. This means that the graph is going to go from negative 5 to 5. And our period is equal to 2 pi over b. And we said b was 1. So period is still 2 pi. So those would be our answers. Let's see. Y is equal to negative sine 7x. And our a is a number before the sine, which is a negative 1. And our b is number before x, which is 7. So our amplitude would be the absolute value of negative 1, which will give us 1 again. Now this is going to bounce back and forth between negative 1 and 1, but let's do something a little bit different. If you remember what happens when you have a negative out in front of your function from college algebra, it reflects across your x-axis. So it's still bouncing between negative 1 and 1, it just looks like it's upside down type of deal. Now our period is 2 pi over b, and b we said was 7. So those would be our answers. Yeah, let me save that. What's this section called? Graphs of the sine and cosine functions. Okay, let's look at our next problem. Got y is equal to 2/3 cosine of negative pi over 4x. Well, we can use our even and odd to get rid of any negatives that are inside here, if we wish. We know cosine of a negative angle since cosine's even, we can just drop the negative. So that gives us that right there. Well, a is 2/3, the number in front of our trig function. B is the number in front of our x, which is pi over 4. So our amplitude is the absolute value of a, which is the absolute value of 2/3, which gives us 2/3. Our period is 2 pi over b. So we'll have 2 pi over 4. And again, whenever you have a single fraction down in the denominator, you can flip it and multiply it times your top part. So this gives us 2 pi times 4 over pi. The pi's will cancel there. And we got 2 times 4, which gives us 8. So our period is 8. let's take a look at number 4. Wants us to match a graph. We're taking a look at y is equal to 4 cosine of 2x. And let's first find our amplitude and period. That'll help us figure out what's what. So A is numbers before your cosine, which is 4. B is numbers for your x, which is 2. Our amplitude will be the absolute value of A, which is the absolute value of 4, which is 4. That means it's going to bounce from negative 4 to 4. Our period is going to equal to 2 pi over B, and B we said was 2. So we got 2 pi over 2 or pi. Okay, so we're looking for a period of pi. Remember, the period is where it starts repeating. And then go far enough over with that arrow. That's kind of bad. It should be over here, but here it goes, starts here, comes down to here, starts repeating right here. This should be pi here. I did the arrow in the wrong place. And let's see if I did the arrow in the wrong place here. No, I did it right there. Okay. And here's pi. It should be over this far. So, anyway, period is pi, so it's going to be either A or B. And we said the amplitude is 4, which means it's going to bounce back and forth between positive 4 and negative 4, which would be B as in Bill. So B is our answer. Now, if you don't use amplitude and period, those are pretty simple problems. You just plug in this into your calculator and see which one it matches. Let's take a look at graphing one of these. Okay, so we got y is equal to 5 sine x. And as weird as it sounds, amplitude isn't as important in these first problems. They get much more important when we're talking about shifts. But it kind of handles itself. The period is an important one. But let's go ahead and find the amplitude anyway. The number before our sine is 5, so we got absolute value of 5, which is 5, so that's our amplitude. Our period is 2 pi over b. B is what number is before the x, which is 1. So I got 2 pi over 1 or 2 pi. Now remember, our x is going to be our angle. And this is always 0. And this last one here is always our period, which would be 2 pi. The middle one here is half our period, which is pi. And this is a quarter of our period, which is 2 pi. And this one is 3/4 of our period, which is 3 pi over 2. Okay, our function is y is equal to 5 sine x. So we said here that x is 0, so we'll plug 0 in there. So we got 5 sine of 0 equals. And here we got 5 sine of pi over 2 equals. 5 sine of pi equals. 5 sine of 3 pi over 2 equals. And 5 sine of 2 pi equals. Well, let's go look at our unit circle. Okay, so 0. We look at 0. Sine is our y part, which is 0. So this will be 5 times 0 or 0. At pi over 2, come up here to pi over 2. Sine is our y part, which is 1. So we got 5 times 1, which gives us 5. Here to pi, sine, which is our y part, is back down to 0. 0. Here, sine 3 pi over 2 is negative 1, which gives us negative 5. And the sine of 2 pi is 0, which gives us 0. Okay, so let's graph this. Looks like it goes up to 2 pi. Oops. So here's 2 pi, and again, pi is like 3, so that's like 6. And this is pi. This is pi over 2, and this is 3 pi over 2. First point, 0, 0. Let me put those in red. Maybe that'd be easier to see. Next one is pi over 2, 5. Well, if this distance here is 6, 5 would be, I don't know, let's say right there. We're just sketching, so it doesn't have to be perfect, but it should be fairly close. So, this is pi over 2 and 5, which would be right here. For pi and 0. 3 pi over 2 and negative 5. 3 pi over 2 and negative 5. And 2 pi and 0. That should be there. We know it has to have a little of a curve to it, so I'll give it some curve. Goes like this. And we get that. If you miss your point, just make your point a little bit bigger. You got it covered. Big dot theorem. And what does it tell us anyway? Graph over, show at least 2 cycles. So I'm just going to sketch this. I'm not going to spend any kind of time on it. Watch me screw it up so bad then that... That's just great. There. Try it again. Okay. Probably regret this. Wish I had spent more time. Now, our starting place was here, so I had to go back down to right there. And that's over 2 periods, 2 cycles. Looking at it, you can obviously see, because these go forever, so our domain, which is what they're asking for, is all real numbers, negative infinity, positive infinity. Our range, it bounces back and forth between negative 5 and 5. So, negative 5 to 5 and brackets on them to mean it includes those values. And I might have room to graph there, but I'm not going to even attempt it. I'm going to save that before we go to the next problem. Grab a drink. Okay. Now let's take a look at this one. Got y is equal to negative 2 cosine of 1/8 x. Okay, so our amplitude would be the absolute value of negative 2, which would give us 2. So it's going to bounce back and forth between negative 2 and 2. Our period is going to be 2 pi over b, and b is whatever numbers for your x. So this is going to be 2 pi over 1/8. Again, whenever you have a single fraction downstairs, you can flip it and multiply it times the top part. So this is 2 pi times 8 over 1, which gives us 16 pi. So let's do our t-chart. And try it again. There we go. This is 0. And this down here is our period, which is 16 pi. Always in the middle is half of our period. Well, half times 16 pi gives us 8 pi. This is 1/4 of our period. 1/4 times 16 pi gives us 4 pi. And this is always 3/4 times our period. 3/4 times 16 gives us 48 over 4, which gives us 12 pi. Like that. Okay. Now, y is equal to negative 2 cosine 1/8 x. So I'm going to take each one of these x values and plug them in for the x here. So I got negative 2 times cosine of 1/8 times 0. Gives us negative 2 times cosine, 1/8 times 0 is 0. On this one, I got negative 2 times cosine of 1/8 times 4 pi, which gives us negative 2 cosine, and 4/8 is 1/2, so we got pi over 2. Here we got negative 2 times cosine of 1/8 times 8 pi. The 8's would cancel, and I'd have negative 2 cosine of pi. And here, negative 2 cosine of 1/8 times 12 pi. See, 12 over 8 reduces to 3/2. So we got negative 2 cosine 3 pi over 2. And you can probably guess what the last one's going to be. Negative 2 cosine and then 1/8 times 16 pi, which gives us negative 2 cosine 2 pi. Look at that. Those look familiar? 0, pi over 2, pi, 3 pi over 2, and 2 pi? Yeah. Now if I go look up cosine 0, it's 1. I'll look up at least that one. Here's 0. Cosine is our x part, which is 1. So I got negative 2 times 1, which is negative 2. Now cosine of pi over 2. That's going to give us 0. Again, here's pi over 2. Cosine is our x part, which is 0. Cosine of pi. That's at negative 1. So that gives us a positive 2. Cosine of 3 pi over 2 is back to 0. So negative 2 times 0 is 0. And down to here, 2 pi is the same, or not 2 pi, your period is the same as your starting place. So it's back to 1. So that gives us negative 2. Okay, now let's sketch this. Here's 16 pi. Here's 8 pi. Here's 4 pi, and then here's 12 pi. Now pi is 3, so this is like 12 right here. It bounces back and forth between 2 and negative 2. If that distance is 12, 2 is something like that right there. And negative 2 is something like that, if I were to draw it to scale. Well, first point here is 0, negative 2. So 0, negative 2. What's that there? Next one is 4 pi 0, which is right there. Next one is 8 pi 2, which is right there. 12 pi 0, which is right there. 16 pi negative 2, which would be right there. So I wanted some curve to it. And as good as I can get it, that's one period. Let me eyeball this and try to do second one maybe. That's probably good as I'm going to get. So that would be our graph. Let's show how to do this one on the calculator. Since the period is different on this one, you have to do a little bit more than what we did in just plugging it in. We come up here. We found that our period is 16 pi. So I'm gonna come here, press my y equals, press clear. I put my function in, which was negative 2 cosine of 1/8 x. So 1 divided by 8 x. And then closing parentheses. Now we need to go to our window settings. X min. If we want, if our period is 2 pi, or 16 pi, then I want my x min to be negative 16 pi. So I do negative 16, second, caret, down arrow, and x max I want it to be positive 16 pi. So 16 and then second caret for the pi. There's 16 pi. And x scale, I don't, I suppose this goes by 4 pi's, doesn't it? So let me choose 4 pi. So do 4 second caret. Y min and Y max. Well, if this bounces back and forth between -2 and 2, I want to at least have enough so I can see it. And -4 is actually okay. And all the rest of that's fine, so I just go ahead and push graph. Don't do zoom Z-trig, that'll set it back. Now, unfortunately, the calculator here will not draw it to scale because of how I did the settings. So by hand is the best way to actually see that. If I wanted it to be to scale, I'd go back to my window. I went from -16 pi to +16 pi. You'd want to come down to your Y min and do a -16 pi and to a +16 pi. I think I said scale was 4 pi, so do 4 second caret and then graph. And you see it drawn more to scale. So you look at this and you see the first one didn't give us a true picture, and this one, not quite like what we need to actually see it. So sometimes doing these by hand is the best way to get a little bit better view of what's going on with it. Let's look at another one. We're going to talk more about these 2 sections from now, I think. Might be more in the next section also. If you remember from college algebra, if you got a number at the very end or very beginning, like a +3, -1, whatever it might be, then it shifts up or down. So this will cause our graph to shift down 1. So what we're going to do is we're going to graph this just like normal. And once we come up with a graph, then we'll shift everything down 1 unit. I guess on that top one I didn't tell what the domain and range were. Our domain is still -infinity to +infinity. And our range looks like -2 to 2. Okay. So let's look at just the red there. Well, first thing, amplitude. We have the absolute value of A, which A is what's before your sine, which is 4. So we get the absolute value of 4, which gives us 4. And then we got our period, which is 2 pi over B. Well, B is the number that's before your x, which is pi. So I got 2 pi over pi. Pi's cancel, and I got 2. Now, normally our amplitude would say this bounces back and forth between -1 or -4 and +4. But this is going to shift our entire graph down 1 place. So think about that. You used to go from -4 to +4. If I shift everything down 1 place, then this is going to be at -5, and this will be to 3. So it's going to bounce back and forth between -5 and 3. Well, let's build our t-chart. Again, this is always 0. And let me just write this down. 4 sine of pi over x and this one down here will be our period, which we said was 2. This is half our period, so a half times 2 gives us 1. This is 1/4 of our period. 1/4 times 2 gives us 2/4, or 1/2. And this is 3/4 times our period. 3/4 times 2 gives us 6/4, or 3/2. Okay, so we're going to plug those in. So I got 4 sine of pi times 0, which gives us 4 sine of 0. This one is 4 sine of pi times a half, which gives us 4 sine of pi over 2. This one is 4 times sine of pi times 1, which is 4 sine of pi. This one is 4 sine of, try it again, pi times 3/2, which is 4 sine of 3 pi over 2. And you can probably guess again what this is. This is pi times 2, which is 4 sine of 2 pi. You've seen a pattern, aren't you? See how these are going back to our basics again? 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, sine of 0 is 0. If I were going to look at my unit circle, wherever it's at, here's 0, sine is our y. If I look at pi over 2, here's pi over 2, sine is 1. Back to 0, to -1, and then the 0. You're going to see that enough so you see this pattern. So, you know, goes 0, and then I visualize it going around the unit circle when I'm doing that. 4 times 0 is 0, 4 times 1 is 4, 4 times 0 is 0, 4 times -1 is -4, and 4 times 0 is 0. So now we're ready to graph this. Okay, and it looks like goes to 2. Try it again. Okay. Okay, so here's 2. Still not there. Let's try it again. Here's 2. And then this will be 1. Boy, this isn't going to be real good. 1/2, and then 3/2. Now I'm not writing that real small just so you can't see it. If you look at your y values over here, it's going to bounce between 4 and -4. Well, if this distance here is 2, that's 2. This distance would be 4. And then this distance would be -4. Let's look at our first point, 0, 0. It'll be right there. Our next point is 1/2, 4. So 1/2, 4 would be right there. Next point is 1, 0, which is right there. Then 3/2, -4, which is right there, and 2, 0, which is right there. So it's got to have a little bit of a curve to it. Like that. Now, we said this -1 means we shift the entire graph down one place. And I didn't hardly leave room, did I? Oh, I was trying so hard to. We'll shift everything down one place. Well, if this is 4, then this would be 2, and this would be 3. And that distance is 1, so this would be -1, -2, and -3. If I shift every point down, shift this down 1. If I shift this down 1, shift this down 1, shift this down 1, use your imagination since I can't shift it down 1, and shift this one down 1. Then the blue would be our graph. Like that. So again, you can use shifts on that if you want. If you want to just plug it right into here, you could do that also. Now this is, we want 2 periods, 2 cycles. So this will go down like this, and come back up. Well, you know what I'm trying to accomplish there. Okay. Our domain. Domain is still negative infinity to positive infinity. It'll always be that for sine and cosine. Our range. Well, the low point is negative 5. The high point is 3. So it's going to bounce back and forth between negative 5 and 3. And that's what we said right here when we shifted down 1. Let me save that since I'm out of room. And let's look at our last problem. Okay, so I got y is equal to 3 halves cosine of negative pi over 2 x plus 5 halves. By the way, on these problems, if you do them in your calculator, again, you have to find your period because you have to know what your x min and x max is going to be, and then you also have to have an idea of your amplitudes to see what your y value is going to be. And I'll actually plug this one into my calculator, assuming I don't forget. Calculator, I don't know, it's kind of iffy whether you get the decent picture of the graph. Okay, now remember what we said about even functions. Cosine of a negative, we don't need to worry about that negative. We can just drop it. It'll give us the same graph, as weird as that seems. Now, if we have another number inside with the inside of the cosine, we have to do it a little bit different. But that's a topic for another section. But if you just have a single item in here, single term, then you just do it this way. Okay, so our amplitude. It's the absolute value of a, and a is 3 halves. So it'd be 3 halves, 1.5. So it's going to bounce back and forth between negative 1.5 and positive 1.5 to begin with. But then we're going to do something here. This will be a shift. Positive 5 halves means we're going to shift the entire thing up 5 halves. Now sometimes that's easier to think of in mixed number format, so 2.5. Okay, our period. Our period is 2 pi over b, and b is whatever's before your x, so we're going to have 2 pi over pi over 2. Well, again, you got a single fraction downstairs. You can flip it, take a reciprocal of it, multiply it times the top part. The pi is canceled there, and 2 times 2 gives us 4. So we're going to build our chart. And again, what I'm going to worry about is just this first part right here. And then I'll shift the entire thing up 5.5. So I'm looking at graphing 3 halves cosine of pi over 2x. And we said our period is 4. So this one will go from 0. That's always 0. And this is 4. This is always our period. So we got 1/2 our period here in the middle. 1/2 times 4 gives us 2. This is always 1/4 of a period. 1/4 times 4 gives us 1. And this is always 3/4 of our period, which would give us 3. So we'll plug those in. So we got 3 halves cosine of pi over 2 times 0, which gives us 3 halves cosine. Pi over 2 times 0 is 0. This one will be 3 halves cosine of pi over 2 times 1, which gives us 3 halves cosine of pi over 2. This one will be 3 halves cosine of pi over 2 times 2, which is 3 halves cosine pi. You're sitting there maybe, why don't you just write them down? You know what they're going to be. Well, this is kind of a check to make sure your x values are correct. So 3/2 cosine of pi over 2 times 3. That gives us 3/2 cosine of 3 pi over 2. And this one would be 3/2 cosine of pi over 2 times 4, which gives us 3/2 cosine of 2 pi. Okay. Cosine of 0 is 1. So we got 3/2 times 1, which gives us 3/2. Cosine of pi over 2 is 0. So we got 3/2 times 0, which gives us 0. And all I'm doing, pi over 2, here's pi over 2. Cosine is our x part, so which is 0. I won't refer back to that on these. Cosine of pi is -1, which gives us -3/2. Cosine of 3 pi over 2 is back to 0. 3/2 times 0 is 0. And this is back to our starting place, which was 3/2. So this is 1, like that. Okay. So come down to here. Period is 4. So put 4 there. This will be 2, 1, 3. Try to get those to match your key x points here. And looks like it goes to 3/2 and down to -3/2. 3/2 is 1.5. So if that distance is 1, 3/2, there's 1 there and another half. This right here will be 3/2. And this distance right here will be -3/2. Okay, so let's plot this point. We got 0, 3/2, which is right there. We got 1, 1, 0, which is right here. 2, -3/2, 2, -3/2, which will be right here. 3, 0, and then 4, 3/2. Okay, so let me kind of put a little bit of curve to that. Like that. Now our shift, we said is up 2.5 or up 5/2. So up 2.5 or up 5/2 or 2.5. Let me think this through. Okay, this is 1, so this would be 1/2. So that's 1/2, 2/2, 3/2. This would be 4/2, 5/2, 6/2, 7/2, 8/2. Okay, so each one of these is a half. Well, if it's shifted up, 2.5 or 5/2. That's 1, 2, 3, 4, 5. It'll be right here. This one shifted 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one, oops. Okay, 1, 2, 3, 4, 5. Be right there. This one, 1, 2, 3, 4, 5. Right there. And this one should be at the same place as that. Okay, so draw somewhat of a curve to it. And that's one cycle. Then the other cycle, if I don't screw it up, more or less looks like that. Okay, so our domain. Your domain is -infinity to +infinity. Our range. Low point now has been moved up to 2/2 or 1. And then it looks like it's 3/2, 4/2, 5/2, 6/2, 7/2, 8/2. So before, if my eyes aren't crossing. Now let's graph this in the calculator. Okay, so I'm go to my y equals clear, and I got 3/2, so 3 divided by 2, and then cosine of negative pi over 2, so negative second caret for the pi divided by 2 x closing parentheses plus 5/2. That's 5 divided by 2. And I'm going to go to my window setting. And now you see, look down here. See how bizarre that is? So if you don't change your window setting, you just get weird answers. We said that our period was 4. So I'm going to go from -4 to 4. So -4, enter, 4, enter. And I think it went by ones, if I remember right. So do 1, enter. Now our y min and our y max. This is a little harder. For our amplitude is 3/2, it goes from -3/2 to +3/2. Normally. Oops. I didn't mean to put that up that high. Okay. So -3/2 to +3/2. Now it's shifted up 5/2, which if we add 5/2 to each one of those, that would be 8/2 or 4. And if I add 5/2 to this, that would give us 2/2 or 1. So it looks like if I went from like -1 to maybe 5, I'd get a good picture of it. Now I'll do a scale of 1, like that. And then let's push graph. Now this actually looks fairly decent compared to what I came up with. And the reason why is because the distance of a unit on the x is roughly the same as the distance of the unit on the y. Now when you're all done graphing on those, to set it back to your standard -2 pi to 2 pi, you press zoom and you choose Z trig, number 7. And actually that's not too bad for that right there. Some of them you get the picture, some you can't by doing zoom Z trig. Let me save that. There we go. I think that's the last problem. Look, yeah, that was the last problem. So let me stop the recorder. And let me then stop the other recorder.